Well, hi everyone. Thanks for taking the time to spend with us here at Softchoice. You are in the right spot. We're going to be talking about the AWS outage that occurred back in February, and we're also going to look at 3 steps that can help you avoid it in the future. What we'd like to do, first off, is just get a pulse from you in terms of, your adoption level of Amazon Web Services. And that really just generally helps myself, as well as one of the subject matter experts that I'll be introducing in a few moments, kind of tailor the content to your needs as well. And it just gives us better slant on how to tailor the content for you as well. So I'll just give you a few moments as we wait for people to trickle in here, and rate your level of AWS adoption. Is it first limited to no AWS adoption? Maybe you're in the planning stages. Maybe you've taken a crack at, say, pre-production, looking at maybe test development as a great place to start. And maybe you're more so into the production workloads in AWS. Or perhaps you're in startup mode and you're really looking at more of a cloud-first approach and thinking about the greenfield for new applications. So feel free to weigh in. We'll recap, and then also it'll be a good chance for you to get a sense from other folks as to where you fit in terms of the group we've got together along with your peers today. So thanks for joining us. We'll get started in just about 60 seconds. Feel free to answer our poll, and then we'll get right into the content. Thank you. Okay, well, thanks for joining everybody. Just in case you didn't hear sort of the introduction earlier, you are in the right spot. This is the AWS outage, and looking at ways to mitigate sort of the impacts of that webinar here from Softchoice. What we're trying to do first off is just get a little bit of a gauge of the audience that we have out there today to understand sort of your AWS adoption and understanding sort of how you're thinking about this in terms of your own personal scenario. It really helps myself, as well as one of our subject matter experts that I'll introduce in just a moment, kind of tailor the content to your needs. So please give us a quick snapshot of where you're at in terms of your AWS adoption or public cloud adoption, and then it'll just help us kind of tailor the content even a little bit more effectively for you here today. So again, let us know if you're sort of in the early planning stages, or considering Amazon Web Services. Secondly, looking at potentially some pilot workloads. That could be test dev. It could be looking at something that you're looking at an sort of a backup scenario, or maybe you have production workloads in Amazon. And then finally, perhaps you're looking at a greenfield situation where all net new apps will go into the cloud as your primary designated service. So feel free to weigh in, and we're going to get started here in just 30 seconds. So we'll give you another few moments, and we'll jump right into the content. Thanks for your patience. Okay, well, thanks for all of you for joining, and first of all, thanks for taking our poll off the top. It just really helps us tailor the content to your needs. We're first and foremost going to say that there's not an AWS outage. I know the screen kind of shows that, but what we really wanted to talk about was back in late February, there was a pretty significant outage from AWS, and we wanted to kind of dig into that a little bit further and discuss a little bit about steps everyone that uses the platform could take to sort of future-proof their AWS production workloads. And that's what we're going to be spending a little bit of time on today. In terms of the agenda that we're going to be covering off today, there's quite a bit of rigor that we've put into thinking through this problem, and also consulting with a lot of our clients throughout North America and worldwide to talk about what are some of their considerations, what are some of the things that are stopping them from getting to that place where they do have a fully redundant environment, and also what they need to do about it. I'm very happy to share with you that we're actually going to attempt to simulate an East region failure. So that'll be a pretty exciting piece later on in the webinar. The first thing we're going to talk about, we're going to open up the next slide, and you'll see sort of how we're going to step through the content today. So I find sometimes as we kind of step through this type of content, it's easy enough to get fixated on sort of the, the very, the minutia of actually all the services that come into play here. So we're going to bring it up a level, and then we're going to really dig deep into some of the scenarios that we've heard from our clients. We're going to look at really specifically what actually happened and, what you could do to prevent for that, and we're going to take a look at some of the technical considerations that you could layer into your even an existing environment so that you can start to design for high availability within those workloads or applications, and understand some of the attributes that might be important to helping you prevent that kind of an outage in the future. One of the things we hear about consistently from our clients as well is that, you know what, in the traditional data center space, it's always been 100% in terms of the ratio of spend for high availability. In this scenario, we're going to talk a little bit how you can actually consider a design that actually supports, cost optimization, and then finally we're going to round it out with a little bit of conversation around how you might think about starting that cloud journey with Softchoice. So thanks for coming on this journey with us. First off, let me introduce myself. I should have done that to start, but my name is Richard Carson. I'm the Manager of Partner Marketing here at Softchoice. I really have a great chance to do a lot of studies, spend a lot of time with customers in terms of understanding key priorities and those types of things, and generally spend a lot of time with our practices, of which AWS is one. That's why I'm really excited to introduce our subject matter expert today, who is Michael Lucas. He's our Amazon Web Services practice lead at Softchoice. And I just wanted to say, Michael, welcome to the webinar, and thanks for joining us.
Yeah, thanks, Rich. Happy to be here, and thank you to all of our attendees. My name is Michael Lucas. I'm the AWS practice lead at Softchoice. My focus is growing our AWS practice around this really great technology that I love, and I'm sure a lot of you do as well. So I essentially grow this practice all the way through the sales process and even into our maintenance and professional services, just making sure that everything is up to speed. I actually come from the industry, so I view this as a client would, and if I'm not happy, then in the way that a client would be happy, then I fix it. So, Rich, thanks. I'm going to hand it back to you to finish up.
Absolutely. Michael, and thanks for joining us. One of the things that really interested me when we met, Michael, was that you've actually played the role of the VP of IT at a fairly prominent organization in the past, and I think that's going to help give us a lot of well-rounded experience, not just in terms of getting a solution in place, but also operating it long-term today. So thank you for spending the time with us. Let me just set some context for the day today, and we'll get into some of the content that's going to hopefully shape how you're thinking about outages, how you're thinking about planning architectures in the future as we step forward here. So if you want to take a look at the next slide, I just wanted to make sure you get the most out of today's session. We're going to try and keep this to 45 minutes, and we've got a good amount of question and answer period later on today. So I would look forward to getting those pieces of feedback from you. What you can do is actually use the Q&A window, likely to the right of your screen. Ask those questions, and we'll make sure we spend some time to spend across that. The second thing is, throughout the session, as you've already seen, we're going to actually be doing polling, and this is just a great opportunity to see what your peer feedback is, and we'll circle back on the initial poll, which is where are you in terms of your adoption of Amazon Web Services. Finally, what we're going to be reviewing today is we're going to not just stay at the high level, we're going to go a little bit deeper in terms of some of the architectural considerations. And what we'd like to provide to you is a sample architecture diagram, and we'll review that in detail with you, but it'll be a series of slides that you can actually demonstrate to your leadership, to your team, to kind of give them a little bit of a picture of what you learned today. So we really want to make sure you get that. Stick with us, and we'll make sure you get a copy of that as well. So let's move on a little bit and just set a little bit of big picture context for you today. And when I think about what I'm hearing from my clients, one of the stats that I recently heard from Gartner really rang true, and it's actually coming to life this year in 2017. And it said something that like that 75% of organizations are in fact going to be adopting public cloud, and they're actually going to be acting in sort of a bimodal world, right? This idea that they're going to be functioning in the data center, keeping the lights running, but they're also going to be functioning at a higher level and taking advantage of hybrid IT, or what we would say public cloud. And the challenge with that, though, is that, you know, as organizations make their way through that step, it's going to continue to kind of put new pressures on the organization as they kind of step forward. And what you'll find, and Michael, if you don't mind just advancing a couple slides here, you'll find that some of the findings were that most people will struggle to actually keep the balance between the old and new. And what we want to talk a little bit about today is how you can actually, you know, future-proof some of the architecture decisions that you're actually making from a public cloud perspective. And we're not just talking about keeping the lights on, but how do you actually progress the business, and how do you help to make those services highly available. Just a very quick recap here. We'll just talk a little bit about you know, what we've heard in terms of AWS in the news. Big outage, late February. You know, generally, you know, AWS is boasting a very high SLA, and this is actually a fairly isolated outage in terms of affecting a specific region. But what you'll find is that there are things that can be done to support that. But when we think about it, it had wide-reaching effects, and a lot of it comes down to architectural and planning decisions that need to be taken to future-proof what you're actually doing in the Amazon Web Services space. So if we go ahead, one thing I like to think about is sort of this idea of the evolution. So if you think about adoption over time, a lot of times the business has been coming with new requests, and IT historically has been doing a great job of keeping ahead of a lot of those requests that have been happening over the years. But at some point in the last 2 to 3 years, the consumerization of IT has come into play. And now we just ran a study with about 1,000 IT professionals and 750 line of business professionals. And what we actually found was there was about 57% of line of business leaders that actually indicated that they could actually procure and deliver services faster than IT could. Now, we believe that the promise, and it's reflected by Gartner's study that indicated that 90% of CIOs seek out hybrid IT to deliver the agility required to support the business initiatives. We see that as a huge promise for our customers, and specifically public cloud adoption is part of that. But it also means two other critical success factors: that of data center transformation, basically mirroring the same types of services that are available in the public cloud, and then finally making sure that the network is actually ready to support the new type of traffic load that's actually going to occur between both their on-premise as well as their external premise, their off-premise investments as well. But the things that I would call out in terms of helping us that would actually need to be addressed through this, and what Michael's really going to help us through, is the idea that there's a ton of cost and complexity and that is perceived around doing high availability within the public cloud arena. And that's really what we're going to dig into today, that we can really distill that down to a place where you've got a very clear view of what to do in this area. But what we really wanted to get from you is just a sense of what areas you would like us to kind of zone in on in terms of our talk track today, and also understanding what kind of areas you would like us to hone in on. Two ways you can do that. One is responding to our poll. That'll help us tailor the conversation, but then also in the Q&A window. But we just welcome your feedback in terms of an understanding if you'd like us to focus a little bit more on high availability planning, ongoing operational tips, so let's assume you've got an existing AWS environment, and then finally recovering from an outage. Oh, and the last one, which a lot of people kind of feel is a barrier to them, is this idea of it's going to cost too much to actually do high availability, and generally it's going to really outweigh the benefits. So we'll talk through these at a high level, but we'll dig a little bit deeper based on the majority of the audience responding here as well today. So feel free to chime in on the poll, and then we'll also dig into the Q&A section a little while further. So feel free to add those questions as we kind of move through the content as well today. So Michael, why don't I pass it back over to you? And as I understand, we're actually going to attempt to take down the entire East region, U.S. East region in Amazon today. Is that correct?
Yeah, absolutely. So the point of I believe, the point of this webinar, at least why most of the people are here, obviously we're all happy to hear about Softchoice, right? But the meat here is going to be this multi-regional architecture and regional failure. So what we're going to do here is we're going to discuss concepts and best practices around building a multi-regional architecture in AWS. So we'll touch on some of the services available. We'll talk from a DevOps standpoint, what kind of tooling might you need. We'll also touch on complexity. So, obviously you're going to have an increase in complexity building these multiple architectures, building this multi-region architecture. There are definitely some information security and compliance concerns when considering tackling multiple regions, which we'll touch on in a little bit. And then we'll also talk about cost management and how multi-region architecture doesn't have to be twice as expensive. For those of my sci-fi fans out there, there's a movie called Contact, and in it, one of the primary characters, S.R. Haddon, says, why buy one when you can buy two for twice the price? Well, multi-region architecture is not like that, and so we're going to discuss how we can distribute our workload across regions instead of duplicating it. So first off, for those of you who are new to Amazon Web Services, though, I expect that most of you are engineers, and this will be a technical demo. But for those of you who are new, Amazon Web Services is actually started out as an internal tool at Amazon. They built a platform by which they could deliver compute and servers and databases to their web development teams in order to support their e-commerce platform and sell books. So this actually was very successful internally, and then they realized, hey, we could be successful in delivering this as an application for our customers. So they did it, and now it's the more profitable wing of Amazon. Sorry, Jeff. I know you love Amazon, Jeff Bezos. And I know you love Amazon, but Amazon Web Services is a really, really amazing product. We're all happy that you did it. So from a technical standpoint, Amazon Web Services is really a collection of services billable in micro increments. So if you think about the traditional way in which you might procure compute for your servers, you might think, okay, I'm going to buy a server, and this server will cost me X amount of dollars in hardware and software and uptime and power as well. And then you think about that, okay, this is going to cost me a certain amount of time over the life of this hardware in order to maintain. So you come up with a total cost of ownership for this server over the next, 3 to 5 years, depending on how long you expect its life cycle to be. And then that is your investment. Well, Amazon Web Services is a little different in that it actually bills per hour or even less. So in the case of EC2, Amazon, or the Elastic Compute Cloud, it actually bills per hour based on the size of your VM or your instance. But in the case of a service like AWS Lambda, Lambda actually bills in increments of 100 milliseconds. So allows you to get very granular and only pay for what you use. That is the point here. On-demand pricing is integral to understanding Amazon Web Services. So each of the services, and there are, I want to say 108, either 103 or 108 available through the console, but each service represents a chunk of complex solutions that you would otherwise have to build in-house. So in the case of EC2, which is their Amazon Compute Cloud, is essentially the VM engine behind AWS. It essentially abstracts the hardware aspect. So this is, hardware that you're not having to manage. This is licensing that you don't have to manage. This is networking that you don't have to manage. So they've put those solutions together and they offer them to you for micro incremental billing. And there are also more complex services. If we think about something like AWS Kinesis for stream-based processing, is sort of like Kafka. If you had to implement something similar to Kafka, then Kinesis may be another managed and micro-billable option. Or like EMR, where you could run Hadoop-esque, if you will, workloads in a managed environment. EMR is a solution for that. So there are lots of different things that it offers, lots of different services they offer to make life easier for us ops guys, but also for developers. And one fun metaphor I like to use when talking about Amazon Web Services is that it's a pile of bricks. Again, sorry to my Amazon Web Services guys out there. This is actually a great metaphor. How you stack the bricks in Amazon Web Services matters a lot. So the way in which you piece together these services really makes a difference in the experience you're going to get with Amazon Web Services and the effectiveness with which you're solving your business needs. And of course, it's better than building with mud, which I equate to physical hardware in a lot of cases. So we're going to be talking about regions a lot, so I think it's worth it to dive into, what is a region. Amazon Web Services offers an extensive global infrastructure. They have regions in many different countries. And inside of those regions are a total of 42 availability zones at present. They're always adding new regions and new availability zones. But at present, it's 16 regions and 42 availability zones, unless they added some last night. So within each region, Amazon Web Services will mention that there is a location, a general location. They don't give an address, but they say, okay, for example, the U.S. East region, which you'll notice on the map here covering the Virginia area with the number 5 on it. The U.S. East region is located in Northern Virginia, specifically Ashburn, if I remember correctly. So again, they won't give you the addresses for the data centers here, but inside of that region, U.S. East, there are 5 availability zones. And so the way that they break these out are, each availability zone is essentially a separate data center or a separate infrastructure group that is either geographically separate or at least separated from a physical standpoint. So it has its own track for power, its own networking infrastructure, its own server compute stack, and however they do their hardware. So this way you can sort of separate a failure from the rest of your infrastructure. If you have half of your stuff in one availability zone and half of your stuff in another availability zone, you are protected from some basic physical failures. But obviously, if Virginia were to fall into the ocean, you would lose all of your availability zones. Not that that would ever happen. So recent additions are they've added actually a region in Canada, the Canada Central region, which I don't know the exact location of, but looks like it's near Toronto. So that's really great for our Canada customers here or who are dealing with some data residency issues with all of the availability zones in the US. But if they have compliance considerations where they need to keep their data in Canada, this is a great solution for them. And then other little additions here. Amazon has added Lambda and API gateway support in Mumbai, as well as Amazon Cloud Directory support in the European Union. Not all services are available in all regions, which is something definitely to consider, but there are a few mature regions that have most, if not all. US East 1 is the most popular region because it is the first one that they launch new services into and generally has all of the availability for those services. But again, US West 1 has, most, and they do have some different separation. This information is available online, so I'll have a link to that. Looks like there is a note here in the chat section for the AWS region table. It's a great place to start when looking for information about what services are available in what region. So if I'm a company, I'm a customer here of AWS, why would I think multi-region? Why is it important for me to consider multi-region with its increased complexity and potential cost? Why would I do this? Well, okay, certain common issues would be data residency. Let's say you're a company and maybe you're an international company and you have clients in both the U.S. and Canada, or maybe even across the pond in Europe. And you need to make sure that this data stays within a certain region, a certain area. using multi-regional architecture with your own little custom sauce to ensure your data belongs or is where it belongs is one way you can make sure that that you're compliant with these concerns. Certain services like S3, for example, has replication, automatic replication between availability zones. So you have some built-in redundancy there, but it doesn't replicate across regions unless you specifically tell it to. So this helps with compliance. Other considerations, uptime. Let's say you want to make sure that your application stays up, survives an outage like we did with the S3 outage on February 28th, but also maybe other human error, maybe internally. Let's say many of you, I'm sure, have dealt with and survived a outage caused by a deployment. It happens. Using multi-regional architecture is a nice way for us to isolate deployments. So we could say, take US, if you're looking at this diagram here on the screen, you could take US West 1 out of the DNS rotation, so no production traffic goes to it, and then deploy to it, and then test it. So it's a great way for you to have an entire isolated environment that you can test your changes to before you go live. Other considerations, performance. Using multiple regions is a way for you to keep your data local to your customers. Say you have customers in Japan, in Tokyo, and you'd like for data to be closer there. You could use AWS's regional features to keep your data and compute closest to those customers. Now, there are some simpler ways, of course, to get your data closer to the edge. CloudFront is one example where you can, it's essentially an Akamai type service where you can have a content distribution network managed by AWS and have your content closest. But if you want to bring your compute closest to the edge, multi-region is a great way to do that. So I'd like to run through real quickly here the evolution of an application. And I think many of you have been through this. I know I've been through this for specific workloads. When you start out building your application, or when you first migrated your application to the cloud, if resiliency wasn't a consideration and you were more concerned about function, then you may have this sort of pattern like you see here, where you might have an EC2 instance, that's the C4 thing, and you might have a RDS or MySQL instance, whether or not that's on the EC2 instance. And you're looking at this and think it's really easy to see where our single point of failure is. Basically, every piece is single point of failure. So you might say, okay, I'm going to take the next step and add a load balancer. Well, great, load balancer, that's cool and all, but a load balancer does nothing if I don't have multiple instances. You could add another instance and keep it in this availability zone, but if there's a network failure at the availability zone level, which does happen, you have a lot of traffic, a lot of customers, a lot of people using and customizing public cloud, availability zone outages do happen. They're usually very small and they recover very quickly, but they do happen. So you might think, okay, I'm going to take my network to the next level and I'm going to add an availability zone within one region. In this case, we're looking at VPC East. So we've added a separate subnet. This will be in a separate location, separate data center with separate power and networking and all of those things. So then, next logical step here is to add hardware to that second availability zone. In this case, we've used a technology in AWS called an auto-scaling group, where we can dynamically scale our count of compute instances across multiple availability zones. This can be more than 2. It can be 3, 4, or in the case of US East, there are 5 availability zones. You could use all 5. 2 is just, we have 2 eyes, 2 ears, 2 hearts, that kind of thing. It's a great number. So we've used this auto-scaling group to scale compute across these 2 availability zones. And one great advantage of using an auto-scaling group is actually a concept of self-healing architecture. Let's say one of these servers were to fail, whether that's because the application failed and could not recover itself, or if there is a hardware failure or anything of that nature, reachability failure. The auto-scaling group would actually terminate the failed instance based off of communication with the load balancer, and then recover it, automatically add a new instance, and as well as automatically distribute them across availability zones. Really great feature, and I encourage all of you to look into auto-scaling groups for these types of workloads. So then you still notice one single point of failure here at our data layer, which is our MySQL instance here. If we were to use RDS for this MySQL instance, then it is simply a checkbox to add another instance in a separate availability zone. RDS, which is Amazon Web Services database service, stands for Relational Database Service, offers many different engines, MySQL, Oracle, Microsoft SQL, their own custom Aurora, as well as newly added PostgreSQL. So the idea here is we've added another instance in multi-availability zone functionality, which means that if the master were to fail, the slave takes over and traffic is automatically rerouted to the working node. And here you have it, one single regional workload infrastructure architecture. So at the region level, there are some shared resources. So, you know, we have S3 buckets are regional. They're not global, they're regional. CloudWatch is regional. Other services like Simple Notification Service or Simple Email Service, SES, or, you know, many others. This application may have some regional resources, which we would make sure that we name them appropriately to belong in this specific region. So here we are, fully resilient, single regional architecture. But you know, what happens if we have a failure like we did with the outage on February 25th? You won't be able to launch new instances or deliver new code to the instances. You know, in a lot of cases, couldn't even access the console. So what do you do in this case? Well, we think multi-region. So you'll notice we've essentially copied the infrastructure for our single region in VPC East to VPC West. Now, you know, if we're considering what this might look like in production, companies could have hundreds of workloads like this. So the increase in complexity of, you know, 100% increase in complexity definitely carries some weight. So best practices that we can use while considering multi-regional architecture is infrastructure as code. If you're using something like Terraform or CloudFormation, it's very easy to duplicate this infrastructure in a very highly accurate way. And then if you're, again, using Terraform, you can very easily audit this infrastructure, and the, honestly, you know, potentially thousands of configuration points for this diagram you're seeing here can be automatically audited using something like Terraform, which is a very great tool. Softchoice does have some IP around this. I've used Terraform in the past, and I think a lot of people have as well, and it's a great tool. But CloudFormation, again, is AWS's built-in supported solution for infrastructure as code. Both are really great tools. It's really just a matter of preference. So at this point, I'd like to just launch into our actual demo. I'm excited. I know you're excited. In this demo, we are going to simulate a regional failure. Now, I promise I will not actually take down a region in AWS. You know, you don't have to go and inform your ops teams or your boss. This is just going to be a security group change, which I'll show you how to do in a moment. And we're going to simulate traffic stopping and to a single region, and then see how a multi-regional architecture may recover from this sort of thing. So we'll hop out of here and into my running loop. So what you'll notice here is a terminal window. Some of you are comfortable with it. Some of you are scared by it. That's okay. This terminal window has three panes. One on the left would be our global endpoint. So what you're seeing here is a looping request. And this looping request is hitting our global endpoint. And our global endpoint, in this case, is just a Route 53 DNS entry with weighted balancing, which we can discuss later via Q&A at the end of this presentation if you'd like to get some more info on how this is done. And it sort of randomly selects a specific region to send traffic to. In this case, you see East and West as both viable endpoints. In the middle, you see a looping request specifically to the East endpoint. This would actually go to our load balancer in the East region. If we think back to our diagram, this would be the load balancer just outside that region or within that region. And on the right, we have our West. I've used color coding so we can very easily pick out the differences. I hope that helps. So what we're going to do is we're just going to hop out of this terminal here, go into my test environment, and we're going to select a security group that I have applied to the load balancer for the US East region. So I know that I'm in the East region because in the console I see North Virginia here, but you could use this dialog box to switch to any region in the world. So in this case, we're using US East Virginia. I'm going to edit this security group that is, again, applied to my load balancer to prevent traffic coming to the ELB on port 80. Security groups are a really great feature to ensure that only the ports that you specify are accessible by individual resources in AWS. And it applies to a lot of different things, not just EC2 instances or ELB, but also databases and things of that nature. So we'll just go ahead and click Save and quickly switch back to our terminal so we can watch the failure. So you'll notice here we start seeing failures in the middle column for traffic going to the east region. So we no longer have responses. We see the date, but we no longer have a response from our web server. And on the global endpoint, you'll notice that we have a little bit of instability. Traffic that would have been forwarded to the US East region is now failing. But within about 10 seconds of this failure, we've configured some automation that detects that the East load balancer has gone down. It's no longer accessible. And runs a little bit of automation. Again, this is all supported features within AWS. Runs a little bit of automation to change the DNS entry for our global endpoint to only forward to the west. Now, I didn't have to do anything for this cutover. This was an automated process, and you'll notice that traffic going to the east, or sorry, to the west region in the right column is working fine. Traffic going to the east is failing, and in the global, all of our traffic is going to west. So in the case of a regional failure, we've essentially recovered from it with no sweat. I know 10 seconds can be a lot for some production applications, but it is definitely better than hours while we wait for the region to come up, or as long as it takes you to relaunch infrastructure in a different region, which may not even be an option if there's regional failure. So at this point, we'll just go ahead and switch back out of the terminal, go back to our console, and I'm going to add our port 80 rule back into the security group. So in doing this, I'm actually allowing traffic back into the load balancer, and then we're going to see how our application handles that. So we'll click Save, switch back to our terminal. So you'll notice that the east loop immediately begins to function again. And then the global endpoint, after, again, within 10 seconds, should detect that the east load balancer is back up and then begin routing traffic to the east as well as to the west region. So there are things you can do to prevent this from triggering when it's not supposed to trigger. There are thresholds. You could set very, very custom health checks that route to custom logic that look at the health and status of multiple microservices, or this could even be done manually. But just we've used automation in our case because it's easier and I only have one mouse. So we'll go ahead and switch out of here and drop back into my presentation. For those of you who would like to make fun of my Mac, please do so. It's fine. I will accept it. So we did it. We've successfully simulated a regional failure and recovered, and I'm sure this would look a lot slicker and happier in production and in bragging to your boss after you've implemented this multi-regional architecture and recovered from a failure with no sweat. But this is our example, and I hope you enjoyed it. So at this point, it's beneficial now to talk about cost. So a lot of people think, okay, well, if I want to have multi-regional architecture, do I really have to pay for twice the infrastructure? Which in a lot of cases, for physical infrastructure, you would have to pay twice the cost to replicate your physical infrastructure in a separate geographic location, as well as all the maintenance tasks involved with that and flying your key staff out to configure it if that's a consideration. But in AWS, because everything can be configured through a single pane of glass, but is also very independent for recovery purposes, we can actually see a much more effective scale here. So consider a single region. If our instances are C4 2x large, which I remember, if I remember correctly, this is something like either 8 or 16 cores on a server and a certain amount of memory. We could have two C4 2x largers for high availability in a single region. We could have one multi-availability zone DB instance for our data layer and RDS, and then one load balancer for a total cost of $1,136.08 per month. This does not include data transfer costs or little incidentals here and there for changes, but this would be a general price. And then if we were to consider multi-region, what we could do is we could actually take these instance sizes and split them in half and distribute our compute across regions. If we're distributing our traffic, it makes sense to distribute our load. So we might have, in this case, 2 C4X large, which is half the size of the 2X large, 2 of those in each region. 2 multi-availability zone databases, 1 of those in each region. But again, the multi-availability zone RDS instance is really a 2 count. And then a total of 2 load balancers, 1 for each region, for a total of $1,177.08 per month, for a grand total difference between single and multi-region architecture of $41 per month, or in this case, a 3.7% increase. If you're using larger instances or more instances, this may actually be even less because the only overhead we're seeing here is the extra cost for the load balancer at a static $18 per month, and the storage for the database layer because we have to have, in this case I calculated 100 gigabytes per RDS instance, and we were doubling the amount of RDS instances for our multi-region. So the overhead here is very, very low, and we'll obviously you have to consider your workload, the type of traffic, the amount of compute, and then whether or not you can scale your infrastructure. For example, let's say the average across our multi-regional architecture is 80% CPU utilization. Well, if you were to move all traffic suddenly to one region, you may have stability issues. So you'll want to build in some actual auto scaling, some real auto scaling into that infrastructure where you automatically add servers based off CPU utilization. This is supported functionality in AWS. It's not too difficult to implement. All right, so that concludes our cost considerations as well as our demo. I'd like to launch real quick here into sort of our philosophy on the stages of adoption that a company may go through when they're considering either migrating to the cloud, leveraging the cloud more, or even doing something like what we've demonstrated in this webinar here, implementing multi-regional architecture. So first step is always gap analysis. We want to understand, what do we have today and where do we want to be, and how much is that going to cost. Softchoice actually offers something called a tech check in which we would help you to analyze the cost and a very simple gap analysis on where you want to go, whether it's migrating to the cloud or considering multi-region. Next step after you perform your gap analysis is generally to just get moving. You pick up production workload. It's actually a core tenet of DevOps to iteratively or incrementally improve your process. So using one production workload for your guinea pig, as it were, is a great experiment for developing a pattern, a repeatable pattern that can be used across workloads. Once you've developed a solution, a repeatable pattern, the rest is just scale. And infrastructure as code is a key aspect of this. So planning, we need to really understand our applications in order to consider whether or not they're viable for the cloud and what a migration to the cloud would look like. We want to consider what our roadblocks are and our adoptions, and again, what will the strategy cost of this? Not just the actual cost of the cloud technology, but how is this going to impact our business and the way that we procure? So Softchoice actually offers this really cool product or service called the Workload Analyzer. It's kind of deceptive. It's not just a tool. It definitely includes human input and thought. But the idea behind the Workload Analyzer is to understand at an application level, so we are thinking application-centric here, what your workload looks like now, what it should look like in the cloud, and whether or not it's even fit for a cloud migration. Some workloads are not. So Softchoice can help you decide, even at scale, when we're talking thousands of workloads, what this would look like, whether your applications are good for the cloud, help you to map out dependencies, which can be very vast, and there can definitely be some confusion or tribal knowledge around dependencies. So we can help you to discover those. And then, of course, the step of migration. Let's actually do it. Let's actually get the infrastructure up. Let's actually, whether that's, you do it yourself or you engage Softchoice's professional services to get this done. We want to actually get a workload in the cloud. you know, we would leverage our infrastructure as service for this. We would consider our deployment methodologies, our DevOps processes. You know, how are we doing patching? How are we updating our code base? There are lots of tools within AWS to help with this, but you know, it also just takes some knowledge in how to adopt these tools and use them correctly. And then once we've migrated, we optimize. Continual optimization. You know, core tenet of DevOps is, again, you know, just iterative improvement. Once we get it in and we measure it, you know, how do we measure our performance metrics? Is this up? Is it performant? You know, are deployments going quickly and smoothly? How many deployment failures do we have? Things like this. Once you gain this sort of measurement and this insight, you can determine whether this whole process was even profitable. And in a lot of cases, it can be. And then if it wasn't, you know, we fix that and we learn from it and we apply that then to the beginning of this list for the next workload we run. So, this is sort of our Softchoice's philosophy with cloud migrations or adopting any sort of new technology. So next steps, we really encourage you guys to look into this technology. Amazon Web Services is an amazing product, offers so much functionality, offers the capability to solve problems in a very custom way. So we encourage everybody to just get their hands in and get dirty because it is on-demand pricing and incremental. It's very easy to pull up an Amazon Web Services account, leverage the free tier, and just use it for free or very cheaply, even, you know, dollars a month, a few dollars a month, to start playing with some small servers and infrastructure and services and see what you can get. So we encourage you to play with it, we really do. And then if you'd like to get a jump start in this learning process, again, Softchoice offers our tech check assessment where we can help with gap analysis and cost management as well as forecasting. But we also offer our Web Foundations Accelerator for AWS. Now, this accelerator is essentially a workshop, whether that's in-house, you know, in person or via webinar format. We would work directly with your engineers to help them to adopt best practices in AWS and understand what that means for their applications. Each of these accelerator courses would really be tailored to a specific workload in your environment, and either your in-house DevOps team or ops team or development team will be able to take what they learn there and apply it to future workloads. It's definitely a valuable engagement for everyone. So if you're interested in either of these services, you know, reach out to one of our sales engineers or to me or to Rich, and, you know, we can help you get started and figure out what this looks like. So at this point, I'm going to pass the webinar back to Rich. I'm sure you're all tired of listening to me talk. Hopefully, I've been kept my voice dynamic enough that I'm not entirely boring. But I'll pass it back to Rich so we can discuss the poll and wrap up the webinar. Thank you all so much for listening and for joining in.
Yeah, thank you, Michael. You know, the first thing I'd say is just while we stepped through a lot of information and we've been having a number of questions come in throughout the duration of the presentation. But the one thing I think we accomplished, Michael, was we broke the East region, or we simulated it, I guess was the take, right?
We broke the internet. Yes, we did.
Broke the internet. There we go. There we go. Well, I just wanted to dig into a few questions. And I think maybe some of these you've picked up or concluded on as well, but one that stood out for me at least was from Frank. He indicated if he was asking a little bit about where to put the primary production workload, and he had asked if I was to pick a region as my primary production region, which one should I pick? How would you kind of go about assessing that, Michael?
So there are only 11 people in this attendee list, but if there were, you know, for example, a few thousand, and I said, everybody use the U.S. East region right now, you know, that might be a bad practice. If I were to consider what region you should start with, though, U.S. East 1 is a great place to start. And the reason why I recommend that is because it has availability for all of the individual services, so you can experiment with your workload and see what it looks like. But if your workload is like simpler, you know, say it's just EC2 instances, RDS for the database layer, I mean, really any region works. So I would consider, one, you know, what's the availability for the services you want to leverage? Two, Data compliance considerations, so does your data need to belong in a specific place, whether that's in the US, Canada, or another country, and are you allowed to have that data elsewhere? And then 3, performance. Is it close enough to your customers? Those are the things you need to ask yourself when you're thinking about which region to adopt.
Great. Thanks, Michael. And Frank, if that didn't answer your question, feel free to chime back in and let's go deeper. You may have already answered this, and I think, generally you kind of chalked it up to about 3.7%, if I remember correctly, around just sort of the cost of doing multi-region across 2 regions. But Simon had asked, and Simon, let me just try and paraphrase here. Apparently they only use US East as their production AWS region. Any simple math that could help size that cost implication for multi-region architecture? Would it be fair, Michael, to say that 3.7% or generally somewhere around there is fair, or are there other considerations?
So 3.7% is definitely not a universal number here. When we're thinking about what our cost is going to be multi-region, we need to take an application-centric approach, consider what resources we're using, and whether or not those resources can be distributed. So the reason why my example was so cost-effective was because I literally, okay, not literally, figuratively, cut my compute pool. So if we think of compute as just a count of cores, if we cut our compute pool in half, put one half in one region and one half in another, and the only overhead was the stuff that we could not cut in half, which in this case was the provisioned storage in our RDS instances. So it may be that you're using something maybe a little more edgy, like DynamoDB for your data storage, where data costs are very, very low, and the majority of the cost is provision, read, and write. You could actually get that percentage lower because you could ensure that you are not accruing waste here, and that you're not duplicating effort or storage costs. But in the case of something where you're using maybe Oracle or maybe Microsoft SQL, where there's licensing considerations, AWS does support on-demand, pay-as-you-go licensing for certain things, but if you're bringing your own license, you want to make sure that you're considering whether or not you're going to be charged double for your licensing costs. So it definitely needs to be considered on a case-by-case basis, but if you're able to cut your compute and your storage in half and store each in each individual region, you can make it very, very cost-effective. Now, actually the last question, I forget the name of the person who asked this question, but the question was, which one should I choose as my primary? Theoretically, you don't have to have a primary. If you're thinking distributed, it can be A, B, and C, not 1, 2, and 3, where all of our regions have the same amount of traffic. It's all about cutting it in half.
Hey, thanks, Michael. Simon, if that didn't get to the heart of your answer, please chime back in if there's some more specific things. Another question that came up here. It comes from Zamban. Zamban, I hope hope that was a correct pronunciation. Question is, new to AWS here, you mentioned managed AWS services versus just regular services. Can you explain?
Sure. So within AWS, there is a concept of shared responsibility. So shared responsibility is the way in which AWS defines what they're going to do and what they expect you to do. So here's a use case. Let's say you want to launch a server in the cloud. Let's say you choose AWS and you're going to launch an EC2, Elastic Compute Cloud instance, running Linux, Ubuntu Linux, because I like Linux. It could be just Windows or anything. So the things that AWS are going to take care of is maintenance and uptime for the network, the connection to the internet for that instance. They're going to take care of the hardware. So if there's a hardware failure on the actual server, they'll migrate your VM to a different stack. They'll take care of the security considerations surrounding the infrastructure. So they're responsible for any sort of security breach surrounding the configuration of their networking infrastructure, their internal systems. And the things that they're going to expect you to do, so this would be outside of their part of the shared responsibility model, are to maintain your server, that, patching, keep your code running. The configuration is actually within the customer's section of the shared responsibility model. So if you open up, for example, port 3389 to the world and have no password on your administrator account, you're going to find people are going to be remote desktoping into your instance. So it's actually your responsibility to make sure that your security group rules and the security of your actual operating system are up to snuff. And they let the customer take care of this because they want to have a maximum amount of flexibility. They're not going to say, oh, no, you can't open up RDP to the world, because maybe that's what you want to do, and maybe you have some other compensating controls in place to take care of this. So to answer the meat of your question, what's the difference between a managed service and an unmanaged service? Well, they're really all managed services, but when I say managed, what I mean is that AWS's portion of the shared responsibility model is larger. So case in point for that, let's say you want to use a database. You could launch an EC2 instance, install MySQL on the EC2 instance, and put your data on there, and you would be responsible for the operating system. You'd be responsible for the database technology and for patching the database technology and making sure that that is up to date, as well as your maintenance windows for patching that. If you fail in patching or you break the database in an EC2 instance, it's going to be your responsibility your responsibility to get it up and running, as well as considerations for backup. If you use RDS, Relational Database Service, they actually maintain the database software. They maintain the patching process and allow you to configure scheduling. They maintain all the way through the application. What you maintain is the actual data that goes on it, your MySQL users, and so login credentials for the actual database. So we're extending AWS's managed umbrella further into this service, providing value to you, because now there's less things as an operations team that you need to maintain. Hopefully that answers your question.
Absolutely. Feel free to chime back in there, Zambane, if that didn't address it, but great overview. I just wanted to call out to Mark. Mark, thanks for all the great links throughout the session today. He's been just chiming in with a number of great resources, so I appreciate that. During the demo, Mark had asked if the sort of the ping packets that you were driving to the different regions, if they were ICMP, and hopefully I'm addressing that correctly, if they were ICMP packages or something else.
Sure. I told myself I wouldn't go into code, but I'm super tempted. So what I did was I wrote this quick little script here that is just doing a curl call to the individual endpoints. So almost like you would pull it up in a browser. In fact, if we were to grab the endpoint for API 1 here and pop that in, we would actually see East. So I'm just grabbing the content of the web page that this infrastructure is hosted in, or is hosting. And then what I'm doing is just kind of like coloring it basically, and then delivering it. So we end up with this. ICMP is, if we actually look into the security group rules that are available in AWS, you can allow actual pings ICMP, but again, this is just port 80 traffic and using curl.
Nice, thank you, Michael. Okay, I think we've got 2 minutes left, so I'm going to do one more question. This one comes from Kaz. Question is really around high availability and how should you really assess the right high availability in air quotes? How do you balance cost and complexity with the effort it might take to get there?
This is always a question that an organization has to ask itself. And it's a question that you have to ask yourself per workload. So you may have several services, you may have a user interface, you may have an API, you may have so on and so forth. You have to look at each one of these workloads and say, okay, how much can I tolerate? For how long can this service go down before I start losing money? Now, I've worked in organizations where an hour of downtime means $40,000 lost, like just right down the hole, boom. And I know of organizations that an hour of downtime would cost a whole lot more than that. But then there are also certain circumstances where your workload might not be super important. Maybe you have some caching built around this workload where you only have to get an answer from an API once per hour, and then in which case that API can go down for a certain period of time. So again, it's a question you have to ask per workload. What are your points of failure? How long would it take you to recover from each of these individual failures? And then tie that into your revenue stream. So there's no overall global answer. It's definitely something that has to be done per each scenario.
Great. Well, that brings us to the top of the hour, and I know we had about 40 minutes of content and lots of good discussion here as well today. Michael, I just want to say thank you to you for sharing a lot of insight, breaking the internet apparently, and really just helping us through this conversation. For those of you that attended and spent the hour with us, I really do appreciate it. You'll see a poll come up. Really do take the time to fill that out and give us your feedback on how we can make this better for next time. Our next session will likely be coming up in just next month, probably about 20 to 30 days from now, and we look forward to you joining us. So as always, appreciate the time, and look forward to engaging with you further. Thanks for all of us here at Softchoice. Bye for now.
Thanks, Rich. Thanks, everybody who attended. See ya. Have a good day.